Ben Pearson, the Roadster Tracker. We recently saw a veiling of the second image from the Event Horizon Telescope, which is a collection of telescopes from all across the globe, radio telescopes, which are used to look at detailed objects of things, particularly black holes. And there are some questions that you guys have had about what we could do to improve that image. And so let's talk about what the technology actually was that led for these to be possible and how we can improve them. The Event Horizon Telescope is a collection of radio telescopes that are linked together as one using something called interferometry. The kind of easiest way to explain this is you take images of the light coming in, and if you can piece together the two pieces and record with enough information, you can combine these together to be able to tell distances better than you would otherwise. So if we have two telescopes that are right here, then an interferometry telescope would be able to tell, say, where this pinky is versus maybe something that's down here. And you get some kind of a sense as to where it is, what the relative distance is between the two telescopes. And this works by combining the wavelengths together. The limitations, though, are kind of interesting, and it's kind of important to understand this. See, if we have these same two telescopes and you have something that's right here versus something that's right here, well, it's going a long axis and it's equal distance between the two different points. And so you're not going to be able to tell exactly where it is. And there's another thing that is a little bit harder to explain, but if the wavelength is such that you're going to pass through one wavelength, then you're also going to have problems telling the distance between the two. And so what the bottom line is to get a higher image, you need more than just 2 points. You need a lot of points. Theoretically, you'll have the resolution as if it's a giant telescope if you have 2 points on opposite ends of the Earth. But with only these 2 points, you'll have a high resolution, but only essentially along one line. And it will be rather limited in its actual usefulness. But when you combine it together with a number of these telescopes, you can get some pretty sharp looking images. It also takes some pretty fancy computer processing because, you know, if you have 2 points here and you have a point here versus another one out here, it is a little bit fuzzier as to where it actually is. So the way that the Event Horizon Telescope works is by using telescopes that are scattered all throughout the globe. And these telescopes have different baselines, which is the distance between them, and they also have different angles, orientations, and both of these are critical to achieving best success. If orientation was all that mattered, then you could have an equilateral triangle and you'd get the best shape. But it turns out really irregular types of shapes are what actually gives the best performance when you're talking about this kind of large baseline interferometry. For a much smaller scale one, the VLBI, Very Large Baseline Interferometry, has telescopes that can be moved around at a single site. And they very specifically set it up so that the orientations and the distances are different for all of these to allow them to combine them together to get a more perfect image. One of the things that I had long thought is, well, why don't you just set up one of these telescopes on like all of the planets? And then you have this ginormous baseline that can capture everything, and that will just work really perfectly, won't it? Well, not really. The problem is that you get the angle in one direction, but you actually need multiple of these together. And yeah, all of the planets would give you some fairly good information because you have these large baselines along with different angles, but you would also need to get some different orientations at these long angles. So you'd have like a sharp image in this direction, but you know, in this direction you wouldn't have much of an image and it could be rather problematic. The way that the Event Horizon Telescope works is the rotation of the Earth changed these orientations and baselines among all the telescopes, which allowed them to get a much sharper image. Now they've done this with 2 different black holes. The first one, I believe it's M87 that they released, is ginormous. Like this thing is bigger than our solar system. The event horizon of this would encompass almost the entire Kuiper Belt. It's so mind-bogglingly large that it's just hard to even really fathom how big it is. The one that they released now is Sagittarius A star, which is the black hole that is at the center of our galaxy. And that one is much closer, but it's also much smaller. They had some interesting issues. They're about the same size in the sky, but because you had to rotate the Earth to get the image at its absolute pristine state, then the image could move. And the stuff that's circling around the black hole, the stuff that we can actually see, that stuff is moving essentially at the speed of light, which is the fastest that anything can move. Now, for Sagittarius A star, which is, we could fit inside of the orbit of Mercury, you know, the speed of light is in the minute. So this stuff is swirling around constantly, and you're having to try to get a good picture of it when it's all moving around. The M87 black hole, it isn't moving around nearly as much. Even though it's moving just as fast, it has a lot further to go. And so over the space of an hour or two, it really hasn't moved around that much. When the light distance to Pluto is like 5 hours, an hour or two it's moved maybe a quarter of an orbit versus multiple times for the Sagittarius A star. The real trick to doing something is not to get, put one of these on the moon and to get one extra long baseline, which would be kind of nice. But what you really want is to have multiple of these and to be able to have a variety of these quickly. So what would actually work really nifty for the Event Horizon Telescope is to have a dedicated space telescope that was participating. And the reason is this would move so fast that it would allow for multiple different baselines when you combine them with the data on Earth. And such, you could assemble a ginormous telescope and you could take these images much, much faster. Since black holes are moving so quickly, it could be enormously valuable. And what would be really great is if you got maybe 2 of them that were in an opposite plane, or maybe you get one that's in a medium Earth orbit, or something to shake up these baselines and these orientations a little bit. And those would be infinitely more valuable than one on the moon, and also a lot easier to get there. Hopefully someday we'll get telescopes that will have this kind of precision. But until then, hopefully we'll be able to keep getting some more. I don't know that they have any specific targets in mind for another black hole. The 2 that I had heard of were Sagittarius A star and M87. They do have a few secondary ones that they're going to no doubt try, and hopefully they'll be able to keep going with this science. Thank you guys for everything. Let me know whatever questions or comments you guys have. Till next time, keep on tracking. Take care.